everyone. In this video, it will be demonstrated the utility of the metabolism similarity analysis. Usually, the chemicals are compared with respect to their structural, parametric, and/or biological similarity. The metabolic similarity between chemicals is the next step of this comparison analysis. Part 1 of this video addresses the cases where the metabolic similarity could additionally support the consistency between chemicals with respect to a target endpoint. In the next, part 2 of this video, the metabolic similarity will be used to justify contradictory results for structurally similar chemicals. The metabolism similarity tool, implemented in TIMES, allows comparison between the simulated metabolic maps of the chemicals, taking into account different similarity criteria. So now, let's investigate the skin metabolism similarity between these two amines. Currently, the metabolism similarity tool contains three different similarity criteria. These are transformations, which assess the metabolic similarity between chemicals based on commonality in their simulated metabolic transformations. Profilers, which assess the metabolic similarity between chemicals based on commonality in their structural or reactivity features. And common metabolites assess the metabolic similarity between chemicals based on generation of common metabolites. Each of these three metabolic similarity criteria has individual options that could be adjusted for the purpose. The statistical comparison for each of these options could be in a fingerprint approach, which takes into account the presence or absence of a specific feature, or it could be in a hologram approach, which takes into account the frequency of appearance of this feature. The third option here, quantity, allows comparison of the structural features with respect to the amounts of the generated metabolites. So now, at first, let's compare these two amines with respect to their structural characteristics. For the purpose, we'll use the profilers available in Toolbox. Actually, TIMES is docked to Toolbox, and knowledge from Toolbox could be extracted automatically. Now, let's select Organic Functional Groups and the fingerprint approach. Here, we can see that both chemicals are structurally similar. Let's see more details. The bar diagram shows that the same functional groups are identified in chemical 1 and in chemical 2. The difference here is coming from the tertiary amine organic functional groups, which is identified only in the second chemical, and this could be clearly seen from the chemical structure. Now, let's close this and compare these two amines with respect to their mechanistic consistency with respect to skin sensitization. Again, we'll use profilers from Toolbox. In this case, we'll select protein binding alerts for skin sensitization by Oasis profiler, as this profiler is specifically related to the target endpoint. We'll use hologram approach. And again, we can see that both chemicals are mechanistically consistent. Let's see more details. The bar diagram shows that the same protein binding cohorts are identified in both chemicals. The difference here is only in the frequency of appearance of these awards. For example, bisaldehyde award has the same frequency in both chemicals. However, the aldehyde award has different frequency in both analyzed chemicals. The metabolites with identified common mechanism can be seen in the simulated maps of both chemicals. Now, let's try to compare the simulated maps of these two chemicals with respect to the metabolic transformations which are simulated. All transformations are categorized into more general and more specific level of description. For example, this is geminal decomposition and more specifically geminal hemiaminal decomposition. In our case, we will compare the more specific level of categorization of the transformations. We can compare all transformations or only the transformations with highest probability. Let's compare all transformations. We can see that both chemicals are also metabolically consistent. We can see the results where the bar diagram shows that some molecular transformations that are happening in chemical 2 are not happening in chemical 1. We can see that some of these differences are related to phase 2 transformations. Because phase 2 products are not essential for the skin sensitization effect, let's try to exclude them from the analysis on the metabolic similarity. Now, it can be seen that the metabolism similarity estimate between these two chemicals is increased. Let's see the diagram. Now, phase 1 transformations are compared only. The remaining difference in the transformations are related to endealkylation transformations. And this is not one has amine groups on the both sides of the alkyl chains, while chemical 2 has terminal, tertiary, and alkylated atom. In summary, both analyzed chemicals are structurally, mechanistically, and metabolically similar with respect to skin sensitization. We can conclude that chemical 2 can be used for read-across prediction for the target chemical. Thank you for watching this video and don't forget to like our channel.